Today we're going to talk about definite integrals where you could do substitution or not. Now, on the AP exam, they have been known to ask questions, especially in the multiple choice section, where in order to check to see if you know the method of substitution, they don't get to the final answer. They'll give you something and say, after using U substitution, what do you get? And that's how they check to see if you know how to do U substitution, even if most of the time you undo the chain rule. Okay, so let me show you how this works out in a definite integral. If you don't change the variable, in other words, you don't do a U substitution, you don't have to worry about the limits of integration. This is saying as x goes from 0 to 1, what is the integral of this integrand? And since this is pretty easily set up to do undoing the chain rule, the derivative of pi over 6x is just pi over 6. It's all right there for us. I think most people are pretty confident enough to go, okay, this is going to be the sine of pi over 6 times x evaluated from 0 to 1 and not have to do the U substitution. So then that's going to be sine of pi over 6 minus sine of 0. The sine of pi over 6 is a half, and the sine of 0 is 0, so this is just a half. Now, if you do end up using a U substitution to do the problem, then we need to change the variable of integration into terms of our new variable, right? We need to change the limits of integration. I think I said the variable of integration. I meant the limits of integration into terms of our new variable. Let me show you how that would work out. So we've got this composite function. So I'm going to rewrite. I like having the composite function first. It's almost never written that way, at least in my experience. So let's go through the steps of a U substitution. We could undo the chain rule to do this, right? But again, I want to point out that on the AP exam, they might ask you to do this. I'll show you where they would say stop. So they would tell you what the U is. U is x squared plus 2, although we probably would have guessed that on our own anyway. And then du is equal to 2x dx. You're like, well, great, I don't have a 2x dx. I need to multiply both sides by a half. And I have 1/2 du is equal to x dx. So my integral then becomes the integral, and I'm going to leave off the limits of integration for now, of u cubed times 1/2 du. And now what I need to do is figure out, well, if x goes from 0 to 1, what does u go from and to? So when x is equal to 0, then u is equal to 0 squared plus 2, which is 2. So that's my new lower limit of integration. And if x is equal to 1, u is equal to 1 squared plus 2, which is 3. This is similar to a question that appeared on the AP exam several years ago. They had this, and they said, if you let u be equal to x squared plus 2, what is the resulting integral? And it was something like this. Okay, you had to correctly find this new coefficient, correctly have the integrand was u cubed, although almost nobody missed that part. And you had to have that the limits of integration were from 2 to 3. The nice thing about this is, you know how when we do a u substitution, after we do the integration, we have to switch it back into terms of x? With this, since we've already compensated for that part of it, we can just do the antiderivative, substitute in 3, substitute in 2, subtract, and we're on our merry way. So this is going to be 1/2 times 1/4 of u to the 4th from 2 to 3. So that's going to be 1/8 times 3 to the 4th minus 2 to the 4th. So that's 1/8 of 81 minus 16 is 1/8 of, let's see, that's 65. So let's just make it 65 over 8. Or if you really prefer, 8 1/8. Or if you're one of those people that hate fractions, 8.125. There's frequently one in every group where someone's like, I don't like fractions. Okay. And I'm happy with decimals as long as they're accurate. Those of you who were in my geometry class may remember me make an enormous point of that. 2 1/3 is not 2.3. It's close, but it's not equal. All right, let's do another couple like that. For this problem, the very first thing I would want to do is rewrite it as the quantity 3x plus 1 to the negative 1/2 dx from 1 to 5. You could do this without a u substitution, but just for the practice, we're going to do u substitutions on all of these. So we'll let u be equal to 3x plus 1. Du then is 3 dx. I don't have a 3 dx, so I multiply both sides by 1/3. I get 1/3 du is equal to dx. So now my new integral will have an integrand of u to the negative 1/2 times 1/3 du. And although I wrote it all out on the other one, most people don't take the time to do that because it's usually pretty simple. Substituting in 1 for x, we get that u is 4. Substituting in 5 for x, we get that u is 16. And before we even go on, I go, oh, okay, well, they set this up so that 4 and 16 are both perfect squares. They've set this up so that the numbers are going to come out to be nice. So now we'll take the antiderivative. Adding 1 to the power, we'll have u to the 1/2 multiplying by the reciprocal, that's 2, from 4 to 16. So that'll be 2/3 of 16 to the 1/2, that's 4. 4 to the 1/2, that's 2. So we've got 2 times 2/3 is 4/3. All right, so here we have the integral of tangent times secant squared. This is a little bit unusual because you're like, well, neither of those is a composite function. Secant squared is, but the derivative of secant is not tangent, it's secant tangent, so that's not going to work out very well. But what's the derivative of tangent?
Secant squared.
Secant squared. So what we can do is we can say, okay, I'm going to make my composite be tangent of x raised to the first power. And let this be secant squared x dx. So if I let u be equal to the tangent of x, du is secant squared of x dx. And you're like, okay, that's really kind of nice. So now we'll have the integral of u times du. I just need to figure out what my new limits of integration are. Tangent of 0 is 0. Tangent at pi over 3, you're like, okay, I got to think about that for a minute. Well, remember that tangent is sine over cosine. Sine at pi over 3 is the square root of 3 over 2. Cosine is 1/2. Dividing those, we get the square root of 3. So when I take the antiderivative of u, remember that is to the first power. And that may be helpful to you because it's like, oh, I can use the power rule for antiderivatives. This will be 1/2 of u squared from 0 to the square root of 3. So that's 1/2 of 3 minus 0. It's 3/2, or 1.5, or 1.5. One last problem. For this one, again, you look at it and go, I don't see any composite here. We kind of have to make the composite here because, I mean, I look at that and I go, that's not any simple antiderivative. What we'll do is we'll rewrite that as the integral from 0 to 1 of x squared minus 4 to the negative 1. And the reason we do that is because now the derivative of the inside part would be 2x, which is a constant multiple times what I actually have outside of that composite function. So that's going to work really nicely. So I'll let u be equal to x squared minus 4. du will be 2x dx. So 1/2 du will be x dx, which is what we actually have. So we'll have the integral of u to the negative 1 times 1/2 du. When we substitute 0 in for x, we get that u is negative 4. And when we substitute in 1 for x, we get that u is negative 3. So we have 1/2, and notice, although that's u to the negative 1 power, the power rule for antiderivatives doesn't work when that is negative 1. What is the antiderivative with respect to u of u to the negative 1? Yeah, natural log of, more specifically, the absolute value of u, which is super important on this one, as we can see from our limits of integration. So this is going to be 1/2 of natural log 3 minus the natural log of 4. Sorry, this is supposed to be negative 3. And because, well, they're like, yeah, we can simplify that. What is the natural log of 3 minus the natural log of 4 equal to? 0. Nope. No. They're not the same. Maybe we should quickly review rules of logarithms. The log of a times b is equal to the log of a plus the log of b. The log of a over b is log a minus log b. And b log a is log of a to the b power. Part of it is, again, this is one of those things where you probably used it in this direction from log of a over b to log a minus log b way more than you did it in the other direction. So I've got log 3 minus log 4, natural log 3 minus natural log of 4. This would be 1/2 of the natural log of 3/4. And if we want to push that a little further, we can take the coefficient, make it the exponent. This would be the natural log of the square root of 3/4. Or, if you want to keep pushing it, that would be the natural log of the square root of 3 over 2. I'm not super particular about simplifying it, beyond something like this, or even sometimes I don't even do that. But just know that if this is a multiple choice question on the AP exam, it's unlikely that they'll leave it like this. They're probably going to at least do this, and they may do this or even this last step. And you have to recognize it. And part of the reason that they justify that is, and I think it's fair enough, they're like, this is a math test. And, knowing properties of a logarithm is a prerequisite for taking calculus. Okay, any other questions? Okay.